Okay, the last problem we're going to look at is a center of mass centroid or double integral problem. We're going to do all of those things. So for these type of problems, some people may have seen them on exam too, most people not. So it's worth going over again how to do the double integrals. So this is our density function. And to do this, we remember a couple definitions. What we want is we want this coordinate x bar, y bar, which is given by my over m and mx over m. Okay. And the way we're going to find, so what we're going to need really in each step is m. So we're going to start by finding m, and m is given by, well, it's the double integral over a region, rho of xy dA. So first we want to figure out what our region is. I'm going to call it region R. Okay, so we have a triangle with coordinates 1, 0, 0, 0, and 0, 1. So, here's 1, 1, 0, here's 0, 1, here's 0, 0. So this is our triangle. And we want to make this actually in terms of some functions. So if this is our x-coordinate, this is our y-coordinates, we know that this equation is y equals 0, this equation is x equals 0, and the question is, what is this equation? Well, this point here, we just said is 0, 1, 1, 0, so the slope has to be 1, or negative 1, right? Rise over run is minus 1 over 1. And its y-intercept is 1, so if you work this out, you get y is equal to minus x plus 1. And we could check that because when x is equal to 0, y is equal to 1 up here. When when y is equal to 0, then x has to be equal to 1. Okay, so this is our domain. So really, our mass is given by, we can integrate this either way. I know there's always a question about which way we integrate it. I'm going to integrate with respect to y first. So I'm going to write this as 6 e to the minus 2x minus 3y. I'm going to do dy and then dx. So my inner integral is going to be from 0 to 1 minus x, and my outer integral is going to be from 0 to 1. Now how did I figure that out? Is I'm looking at lines like this. So I'm first going in the y direction. I'm starting here at y equals 0, and I'm going up to the line 1 minus x. And then the x direction, I'm going from 0 to 1. So as long as you have this region covered, you're fine. Alternatively, you could do x and y interchanged. I'm going to do it this way. Okay, so this is going to be 0 to 1. Now I always like to split these integrals up to make it as easy as possible, and I'm going to write this as 6 e to the minus 2x e to the minus 3y by the laws of exponentials. And now, there should be an x in here. Now I notice, all of this stuff is constant with respect to y. Right, so I'm going to bring it out. In fact, I'm going to bring the 6 out of everything. The other stuff I'm going to bring out, and I have e to the minus 2x here. And then I have 0 to 1 minus x, e to the minus 3y dy. And then after I'm done with this integral, I'll do a dx. I'll get the other integral out of the way. So this is 6. I still have this integral, e to the minus 2x. And this one gives us a minus 1 over 3, e to the minus 3y from 0 to 1 minus x dx. So I'm going to have to plug this in, right? So m is equal to 6, 0 to 1. And now I'm going to bring this minus 1/3 out, so I have minus e to the minus 2x over 3, because that's all this stuff. And I have, well, if I evaluate e to the minus 3y at 1 minus x, I get e to the 3 x minus 1 minus, well, e to the 0 is 1, so minus 1 dx. I'm still going to have to integrate with respect to x. I get 6 over 3, which is just 2, right? 6 over 3. Bring that out to integral from 0 to 1. I'll bring out my minus sign as well. And I have e to the minus 2x. Now, if two functions multiply, then their exponentials add. So I have plus 3x minus 3 from this one, right? And then I have minus e to the minus 2x dx. So what does that look like? That's minus 2, 0 to 1, e to the minus 2x plus 3x is e to the x, minus 3 minus e to the minus 2x dx. So that's minus 2. Oops, we're going to actually do the integration step here. So we have e to the x, it gets a plus 1, so e to the x minus 2 over, oops, let's actually be careful about that here, sorry. E to the minus 3 is a constant, right? E to the minus 3 comes out, and then we have, we could write this, for example, as e to the x, e to the minus 3. So we have e to the minus 3, and then we have e to the x minus e to the minus 2, so we're actually going to get a minus 1 half e to the minus 2x. You could check this by taking a derivative. 0 to 1. Oops. So this is minus 2 e to the minus 3 e to the 1 plus 1 half e to the minus 2 minus all the other stuff, and that's e to the 3 e to the 0, which is just 1, e to the minus 3 plus 1 half e to the 0 is just 1. So this is going to be minus 2 e to the minus 3 plus 1, right? These guys, if we look at these terms, this is minus 3 plus 1. So that's going to be e to the minus 2 plus 1 half e to the minus 2 minus e to the minus 3 minus 1 half. Or if we could simplify just a little bit more, this is going to be 3 halves e to the minus 2 minus e to the minus 3 minus 1 half. Okay. And this is just equal to m. So that's the first part of our integral, m. We also need my and mx. So what is my given by? Well, my is equal to the integral of double integral x times rho xy dA. Okay, so what is this going to be? This is going to be, if I keep my same balance, I'm going to go 0 to 1, 0 to 1 minus x, x, e to the, what did I have? Times 6 e to the minus 2x, so I'm going to bring the 6 out front, e to the minus 2x, e to the minus 3y, right? That's what I had, e to the minus 3y, and then this is going to be dy dx. Okay, so once again, this stuff is all x. Let's bring it out. Alright, this is 6, 0 to 1, x e to the minus 2x. And then if I integrate what's left, I have minus 1 over 3, e to the minus 3y, from 0 to 1 minus x, the same way I had before, right? If we look back here, you know, this part's going to be the same. Or rather, this step. Okay, so now we're at this step, and we have 6, 0 to 1, x, e to the minus 2x. Oop, let me go ahead and bring this minus 1/3 out. Erase this guy, and then that gives me a minus 2 again. And then I'm going to have e to the minus 3, 1 minus x, minus 1. Same as I had before. This is going to give me a minus 2, 0 to 1, x e to the minus 2x, e to the minus 3 plus x, minus 1, dx, minus 2, 0 to 1, x. I'm going to bring this inside, so I have e to the minus 3, e to the minus x, right? X minus 2x is minus x, minus e to the minus 2x dx. Okay, so now I have two a little bit tricky integrals. So we're going to have to do these with trig substitution. I'm going to do just one of them here, just so you get an idea of what to do. So let's look at we're just going to look at 0 to 1, x e to the minus 3, e to the minus x, which of course I can write as e to the minus 3, because it's a constant, x e to the minus x dx. Now I'm going to work with this by saying u is equal to x. I always want that one to be the one that goes away. Du is equal to dx. dv is equal to e to the minus x. v is dx. v is minus e to the minus x. Okay, so what we have is our integral e to the minus 3, 0 to 1, x e to the minus x dx is equal to e to the minus 3, and then we do uv, so minus x e to the minus x, that's uv, minus integral v du, so that's minus e to the minus x dx. And then we're going to evaluate all this from 0 to 1. So we get e to the minus 3 minus x e to the minus x. This becomes a plus, right? So this is just a plus and a plus. But then when we integrate this, we'll get a minus sign. So we get minus e to the minus x from 0 to 1, which otherwise can be written minus e to the minus 1 minus e to the minus 1 and then we're going to have minus, well this first term is going to be 0, but this one's going to be 1. So we can write this as e to the minus 3 minus 2 e to the minus 1 plus 1. And that's just part of the integral, right? You're going to have to do this one on your own. So I'll just write it out and then I'll leave it as an exercise. And what is it? X e to the minus 2x dx. Similarly, okay, I'll leave that for practice. And then if you add them, you're just going to get my. Okay, now let's look at mx. The other one, mx is y, rho of xy, dA, which again, we're going to bring out the 6. This is going to go from 0 to 1. This goes to 0 to 1 minus x. And we get y, e to the minus 2x, e to the minus 3y, dy, dx. So we're going to get 6 integral 0 to 1. We can bring out e to the minus 2x, but now we can't bring out the y, right? That one's in there. Okay, now we're going to have to do a integration by parts here. U is equal to y, du is equal to dy, dv is equal to e to the minus 3y, dy, and v is minus 1/3 e to the minus 3y dy. So this whole thing is equal to 6. I still have this integral on the outside, right? E to the minus 2x. And then I have uv, which is minus y over 3 e to the minus 3y minus integral uv, or v du, but this is going to become a plus sign in the integral. So then I'm going to have integral minus e to the minus 3y dy. I'm going to do all this from 0 to 1 minus x. Is equal to 6, 0 to 1, e to the minus 2x. Oh, and at the end we're going to have to do dx, right? I didn't leave myself room here, but we're going to have a dx in here. Okay, so we still have all this stuff. If I plug this in, I'm going to get x minus 1, e to the minus 3, 1 minus x over 3. And then this integral is going to give us a minus 1 over 9 e to the minus 3, 1 minus x. So I recommend checking this, but this is the correct answer. And then we get minus, and if I plug all this in, this one's going to be a 0, and this one's going to be a minus 1/9 e to the 0. Okay, so what does this all look like? It's going to be 6 integral 0, 1 e to the minus 2x. And here we're going to have x minus 1 e to the 3 x minus 1 over 3 plus 1/9 1 minus e to the 3 x minus 1. So I ran out of a little bit of room here, and then it's all going to be dx. Oops. Okay. So I'm not going to do this here, but we're going to have to integrate by parts again. Okay, so this problem's a little bit tricky. You probably won't get anything this hard. It's totally worth practicing your integration by parts to get there. What's important is for this class is the setup. Okay, like I said, the important thing is the setup. That's what we're most interested in doing. You probably won't get anything with this hard of integration by parts. This is just a practice problem. Okay, so in the end, you're going to have found your my and your mx, and be careful. Be careful because, right, y corresponds to the x here, and the x corresponds to the y there. Okay, so once you do that, that's your answer.